This page of notes starts with a review of 3.2, but then we're going to go into lesson 3.3. So first, let's remember that theta equals 2 means that theta is a measure of 2 radians. And if it says 2 degrees, then that means it's a measure of 2 degrees, which are not equivalent in their current form. So an arc is a full circle, in a circle with radius equal to 1, then it is 2 pi. Remember, that was our definition of radian. So here's our formula for arc length involving the central angle and the radius. In a circle, the distance around is 2 pi r. Remember, that's the formula for a perimeter. So if we take s equals 2 pi r and substitute it into our little formula, this formula right here is what they're talking about, we would say theta equals 2 pi r over r. Notice that the r's would cancel out, and you get theta equals 2 pi, which is 2 pi radians, of course. Oh, I think they wanted my work over here. So let's move this out of the way. 360 degrees is 2 pi radians, so 180 degrees is equal to 1 pi radians. And this is just going over how we converted between radians and degrees. So how many degrees is in 1 radian? This is something that you could divide by 180 divided by pi on your calculator, and you get approximately 57.3 degrees. So to convert 75 degrees, remember we multiply by pi over 180 degrees. And we're going to leave it in terms of pi, so on your calculator, 75 divided by 180, math enter, enter, and you'll get 5 pi over 12. Now going the other direction, you have 8 pi over 11. We'd multiply by 180 over pi. This time the pi's will cancel out because we want our answer in degrees. And I just need you to type 8 times 180 divided by 11. And this time we do get a decimal, which typically we don't, but this was a weird radian measurement to begin with, or approximately 130.91 degrees. Okay, now we're going to start the notes on 3.3. Excuse me. The equation for a circle with radius 1 and center at the origin, remember, was x squared plus y squared equals 1. Because the center at the origin means that you have nothing with your x and y, and the radius squared would be 1 still. So we have what's called the unit circle, which we've been kind of hinting at for the last few sections. And when you have a central angle of theta degrees, we create a triangle. And because the radius is 1, the x and y value of that terminal point becomes the cosine and the sine value. And we've also hinted at that before. Remember, the cosine is the x value and the sine is the y value. And that's why it is. So, let's see, if radius is 1 and the sine is y over r, the cosine is x over r, this is just kind of helping with the formulas again. That means that the sine of theta is the y value and the cosine of theta is the x value. So instead of writing a point as x comma y, you could actually write it as cosine comma sine. So again, we're just going back to what we've been hinting at for the last chapter. Let's move on to find the 6 trigonometric functions of 5 pi over 6. So what I would like you to do is look at your reference page for the unit circle and find 5 pi over 6, and the 6 trigonometric functions that they are referring to are these guys. And once we know sine and cosine, which we can find off the unit circle, we can figure out everything else. So let's see, secant and cotangent. Sine of 5 pi over 6 is a 1/2. I'm just looking at the unit circle. Cosine is a negative square root of 3 over 2. Now tangent, remember, is sine divided by cosine. So if I took a 1/2 and divided it by negative 3 square root of 2, that would be like multiplying by his reciprocal. So the 2's would cancel, and if I rationalize my denominator, I'd get negative square root of 3 over 3. Then cosecant is reciprocal of sine, so it's a 2. Secant is reciprocal of cosine, so again, if I flipped it and then rationalize, I have negative 2 square root of 3 over 3. And then cotangent, remember this was negative 1 over square root of 3, so if I just flip that, I get negative square root of 3. The next part says, find all values between 0 and 2 pi, so just do one revolution of your circle, where the cosine of t is 1/2. So when I look at my unit circle, I'm looking for everybody who has an x value that is a positive 1/2. And you should find two places on the unit circle, and they want the radian measurements of them. I see pi over 3, and then the other one is 5 pi over 3. Notice, since we wanted a positive cosine, the first answer I gave you was in quadrant 1, and the second answer I gave you was in quadrant 4, which are the only two places where cosine is positive. Okay. The concept of odd and even functions is actually back from college algebra. A function is odd if, when you plug in a negative value for the x's, so you put in a negative value, it comes out to a negative version of the original function. So from college algebra, remember when you did f of negative x for this particular function. So when I simplify this, I get negative x to the third. Now notice the original function was x to the third. So if I throw a negative in front, that is in fact negative x to the third. So an example for sine would be if I was to plug in a negative x, that would look like this. Sine of negative x. Now this is a little hard for us to understand, so it might help you if you go ahead and, oops, I feel like I skipped a problem. I think well, somehow I left off the even stuff. We'll go back to that in a second. Alright, sine of negative x. It might help you if we actually plug in some data values. So my favorite sine function value is sine of 30 degrees, or pi over 6, because he's nice and easy. So sine of pi over 6 is a 1/2. But what if I did sine of negative pi over 6? So I'd go to my unit circle, negative pi over 6 is down here, and he would be a value of negative 1/2. And what do you know? If you plug in a negative x value, it comes out to the negative answer for the y value of the function. So that's how we can prove that it's odd. And if you think about this, the reason that works is because this is quadrant 1, and this is quadrant 4. Sine is positive in quadrant 1, but if I bring it down to quadrant 4, all of a sudden the sine value is going to be negative, and that's why it works. Show that tangent is an odd function. One way to do it is to put in an example like we have been doing. But if f of x is the tangent of x, and he's in quadrant 1, he's a positive value. Now, if I were to take f of negative x now, that would end up being the negative value of it, because he would end up in quadrant 4, which is obviously a negative value. So they're the same number, it's just the sign itself changes. And then cotangent is also odd, because if tangent is odd, then so is cotangent.
Are you talking to yourself? He does during class.
Alright, so I need to insert a little page here. So I think I didn't copy the even stuff. So go back to your notes where it talks about even functions. If it is an even function, that means that when you plug in a negative x, you end up with the same function all over again. So the example from college algebra was our favorite quadratic x squared. And if you were to plug in a negative x, and then you were to square it, oops, that's an x, you still end up with our original function of x squared. So the only trig function that we're going to talk about as being even is our friend cosine. And again, you could plug in values for x to prove that this is true, but if you were to give you the negative version of x, this would become, okay, cosine of x is in quadrant 1. Now if I do the negative version, we're going to get the same value, because that would end up being in quadrant 4. And remember, all students take calculus. The cosine is still positive in quadrant 4. So if you wanted to plug in some values, that would be fine. Okay. Whoops, one more page. Use even and odd functions to find the exact values. So since sine of negative 60, sine, remember, is an odd function, what that means is he's the same value as the negative sine of 60. So if you knew sine of 60, which is negative square root of 3 over 2, or positive square root of 3 over 2, the negative version of him is negative square root of 3 over 2. Okay. Cosine is even. So what that means is the cosine of negative 225 is the same thing as positive cosine. So if we go to our unit circle and find the value for cosine of 225, we're actually going to have our answer. Okay, cosine of negative 2 pi over 3. Remember, cosine is even. So I could just find the cosine of positive 2 pi over 3, and I would have my answer. So if I look on my unit circle, that comes out to a negative 1/2. And then secant is a relative of cosine, so he is even, which means that if I could find 1 over the cosine of positive 30, I'd have my same answer. So cosine of 30 is square root of 3 over 2. So if I do 1 over that, I end up with 2 over square roots of 3. And when I rationalize, I get 2 square roots of 3 over 3. And that concludes the lesson on 3.3.